be very careful with these. People get confused as to what's the same and what's different, okay? So let's say, for example, if we were trying to add 1/2 and 1/3, okay, we're trying to add 1/2 and 1/3. What would be the least common denominator there? 6, okay? So how do we turn 1/2 into something over 6? We multiply by 3, top and bottom, right? Because that's what's going to turn 2 into 6. So let's apply that logic right here, okay? So both of these denominators in number 7, both of them have an x, okay? They've got that in common. That's not the problem. The problem is one of them has 2x, one of them has 3x. So just like the example I just mentioned, they need to have 6. So the first one, we're going to multiply top and bottom by 3 to turn that into 6x. We're going to multiply the second one, top and bottom, by 2 to turn that into 6x. Now, right now, while we're trying to work this out and learn it, let's write it out as much as we can. So 3 times 15 is 45. That's over 3 times 2x is 6x. Minus 16 times 2 is 32. 3x times 2 is 6x. Now, I know the purpose is that we get a common denominator so that we can combine them, but I want you to do this step right here because I want you to see whether or not you actually have a common denominator. Did you end up with the same thing in both denominators? We did. We ended up with 6x in both denominators, so now we can subtract the numerators. So 45 minus 32 is 13. We don't touch the denominator, okay? Just like we've been doing, don't touch the denominator. So there's our answer. 13 over 6 doesn't simplify, so we're finished with this one. Okay, let's look at 8. Number 8. All right, one of the denominators has a squared, the other one has 8a. So let's deal with the number part first. The second denominator has 8. The first denominator does not have 8. So we need to multiply the first one by 8, top and bottom. The second one has an a, but the first one has an a squared. So how do we fix that? Multiply by an a, top and bottom. So let's see what we've got. 8 times 4a is 32a. 8 times a squared is 8a squared. Minus 7 times a is 7a. 8a times a is 8a squared. Don't just write it down automatically because you know that's what's supposed to be there. Make sure that's what actually ends up there. So we've got the same denominator. Combine our numerators. 32a minus 7a is 25a over 8a squared. 25 over 8. They don't have a common factor, but we can simplify those a's. Okay, a over a squared leaves us with an a in the denominator. Okay, not so bad. Flip your paper over, let's look at number 9. It's still not bad, okay? We're just kicking it up a notch. We went from having monomials in the denominator to now we have binomials. Now, before you look at those two denominators and say that they are completely different, here's what we need to do. If the denominators are factorable, we need to factor them. So is that first denominator factorable? Yes. We can take out a 5, and when we factor out a 5, we are left with k minus 2. Mark out the 5k minus 10. We're not dealing with that anymore. I don't want you to be distracted by that in the denominator. We're focused on 5 times k minus 2, and the other one has k minus 2. So they have k minus 2 in common. We can't factor the second denominator, just put a set of parentheses around it. So they have that part. So the only thing that's missing here is the second one is missing that factor of 5. So we've got k squared plus 16 over 5 times k minus 2 minus 4 times 5 is 20 over 5 times k minus 2. So we have the same denominators. We can combine their numerators. So k squared 16 minus 20 is negative 4. After we combine them, what's the next thing that we're looking for? Can we factor? Can we factor the numerator? Yes. Difference of perfect squares. We are finally starting to recognize that, so that is a win. We leave the denominator in factored form. Okay, there's no reason to multiply that out. Leave it in factored form because now we see that they both have a factor of k minus 2. So this simplifies down to k plus 2 over 5. All right, number 10. First denominator. Factorable? It's a binomial. The only thing that we're looking to factor out of a binomial is a GCF, or is it the difference of perfect squares? It is neither of those, so we leave it. Second denominator. Factorable? Yes. Y times y gives us y squared, plus 8, plus 3. Multiply those, we get 24. Add them, we get 11. So again, mark out the denominator that's there. We don't need it anymore. We've got y plus 8 in both of them. So the first one is just missing the y plus 3. Top and bottom. Okay, so just to save myself a little bit of room, I'm going to distribute the 7 when I rewrite it. So 7y plus 21 over y plus 3 times y plus 8. This is a plus 35 over, I'd rather write those in the same order. It really doesn't matter, but I'm a little OCD like that. Okay, so we have the same denominators. We can now combine their numerators. So 7y plus 56. Next question is, can we factor the numerator so that something simplifies? We can factor the numerator. Take out a GCF of 7, bless you. So those y plus 8s cancel, so we are left with 7 over y plus 3. Okay, now I know there are a bunch of these examples, but there are a bunch of scenarios that we're going to run into with unlike bases, so I want to cover all the bases. Haha. I know, it wasn't funny. All right, let's look at number 11. Y'all know I'm cheesy. Okay, number 11. First denominator, factorable? Yes. X plus 3, x plus 2. The goal is the majority of the time the denominators are going to have something in common, okay? Most of the time they're going to have something in common. So if you're looking at it and wondering if it's factorable, wonder real hard because chances are it is. So when we factor it, they have x plus 2 in common. So that means the second one is missing the x plus 3, top and bottom. So we've got x squared minus 5 over x plus 3 times x plus 2. This is plus. Multiplying by 1 doesn't do anything, so I'm just going to drop those parentheses there on the x plus 3. All right, they have the same denominator, so that means I can combine their numerators. It's addition, so x squared plus x, negative 5 plus 3 is negative 2. Can we factor the numerator? Yes. Use the denominator as a hint. X plus 3 is not going to be a factor, but x plus 2 could be. If x plus 2 is our factor, what's the other factor? X minus 1, right? Because 2 times negative 1 is negative 2. Check it. Outside gives us negative x. Inside gives us positive 2x. So together those give us positive 1x. So now we can cancel the x plus 2's. We are left with x minus 1 over x plus 3. Do not get factor happy or cancel happy and cancel those x's. You can't do it. If you glean nothing else from the whole rational expression things, If all you remember is you can't cancel those x's right here because they're pluses and minuses, I will be a happy math teacher. Okay, I'll be happier if you remember everything, but if you remember that much, I'll be a happy math teacher. Okay, let's look at number 12. Okay, first denominator, what we got? Difference perfect squares, m plus 2 times m minus 2. Now, before we go any further, check out that numerator. Can we factor that numerator? Yeah, we can. Okay, now, I haven't asked that question up until now because we haven't been able to factor any of the other numerators. All the other numerators up to this point have not been factorable. But the reason why I asked this is because if we factor the numerator and the denominator, can we simplify something in that first rational expression there? Yeah, we can. There's an m plus 2 in the numerator and the denominator of that first rational expression. So when we do that, look at what happens. We have common denominators. Okay, we didn't really have to get a common denominator. We just had to find that it was in there. It was just kind of hidden with some extra factors. So if you can do that, if you can simplify from the get-go, simplify from the get-go. Now, you would still get to the same answer. If you didn't see that, if you were just trucking on because you're used to the process we've been doing, you would still get there. You would just have to factor and cancel in the end, okay? You wouldn't get there as quickly as we just did because that just took us, what, 1, 2, 3 steps? Factor and cancel. We got the same thing. I mean, technically, it could have been 2 steps if you hadn't have written that intermediate step. But again, if you didn't see that at the very beginning, not the end of the world, you would still get there if you got a common denominator. You would just have more simplifying to do at the end. Okay? All right, let's look at 13. Okay, we haven't run into this yet. Those two denominators have nothing in common. Okay, yes, they both have a w. Okay, but one is w plus 1 and one is w minus 7. Those are different factors. So the first one needs what the second denominator has, and the second one needs what the first denominator has. Okay, so they had nothing in common, so we got to multiply both of them. Let's go ahead and distribute the 5. 5w minus 35 over w minus 7 times w plus 1, plus, go ahead and distribute the 8. 8w plus 8. Be careful when you're distributing. That messes people up more than anything. All right, so they have the same denominators. Combine their numerators. 5w plus 8w, 13w, negative 35 plus 8, negative 27. Can we factor anything out of that numerator? No. 13 is prime, and it is not a factor of 27, so we are finished. We finally ran into one that did not simplify after we added them. Okay, it doesn't have to simplify every single time. Most of the time it doesn't, or most of the time it does, but sometimes it doesn't. It doesn't have to. Okay, on number 14, this one trips people up more than anything. The b plus 3 is different from just the plain b. Okay, those are different denominators. B plus 3, you have to look at that as a factor. B is a separate factor. So that means the first one is missing the b, the just plain b. The second one is missing the b plus 3. Okay, so b times b is b squared. Now, I think this makes life easier. Go ahead, when you distribute the 4, since it's minus, go ahead and distribute the negative 4. Okay, so that's going to be minus 4b minus 12. And I changed that to a plus sign in between because I distributed a negative 4. Okay, if you would rather just distribute the positive 4 and then remember to apply the negative, that's fine. But I think fewer people make mistakes when they look at it this way. Okay, it's less likely that you're going to miss that negative on the end. All right, so we have the same base. Combine their numerators. B squared minus 4b minus 12 over b times b plus 3. Can we factor the numerator? Yes. B minus 6 times b plus 2. Ooh, that's not what we were expecting, right? But that's the correct factoring. Okay, just because it factors does not guarantee that something's going to simplify and cancel. So just leave it in factored form. Okay, leave it in the factored form there. But nothing simplified. But that's okay. Not the end of the world. Okay? Last two, and then I will stop talking. Okay? 15. First denominator. What do we need to do? Take out a 4. Leaves us with p minus 5. Second denominator. P minus 5 times p minus 3. So, they both have p minus 5. What's the first one missing? P minus 3, top and bottom. What's the second one missing? Just the 4. Make sure you put parentheses around that p minus 6. Okay, make sure you put parentheses around that p minus 6. So, let's distribute the 2. 2p minus 6. And that is over. Put that 4 in front. P minus 3, p minus 5. Plus, distribute that 4. 4p minus 24. Put the 4 in front. Might as well write it in the same order. We have the same denominator. I keep on saying that because I want you to confirm that. Because I see people doing these problems and they don't have the same denominator, but they proceed like they do. Okay? So we have the same denominator, so we combine their numerators. 2p plus 4p, 6p. Negative 6 minus 24, negative 30. All right, top has a GCF, 6 times p minus 5. So what simplifies? P minus 5, is that it? Simplify the 6 and 4. Okay, people always forget to simplify the GCFs. If they're simplified, sometimes you can't simplify them, but you always need to check. So 6 is divisible by 2. Excuse me. 6 is divided by 2. 4 is divisible by 2. So we're left with just a 3 on the top and a 2 times p minus 3 on the bottom. Okay, last one. Number 16. First denominator. What should we do? Pull out a 2. Left with r plus 4. Second denominator. Pull out an r. R plus 4. So they both have r plus 4. What's the first one missing? R. Multiply top and bottom. How about the second one? 2. Top and bottom. R times r squared. Let's write that denominator. 2r times r plus 4. Don't lose the fact that that's a minus. 8 times 2, 16. Okay, I could have done what I did before, but it's just a single term, so most people don't mess that up. It's just when there's more than one term in that second one. All right. Can I factor in the same step? We'll be okay with that. R squared minus 16. R plus 4 times R minus 4. If you need to take an extra step, that's fine. Okay, I think we're to the point where we can do that at the same time. Okay, R plus 4, top and bottom. So we are left with R minus 4 over 2R. Don't get cancel happy. Do not cancel those R's. Do not simplify the 4 over 2 because of that minus in the numerator. Okay, that is all you can do to that problem. If you ever have a question about it, try it and then do what I showed you to check it in your calculator. Plug the original one into Y1, plug yours into Y2. If those Y values don't match, then you canceled something you shouldn't cancel. Okay?